In this program, we'll fade up and down the tones on a speaker using for loops. In the void setup function, use the pin mode function with arguments A5 and output to set up a speaker on your MakerBoard. Within the void loop, we have a for loop. The for loop has four main parts: a variable that is created and set to a starting value, a condition that is checked before the for loop runs, a change to the variable that happens after the code between the curly braces runs, and the code between the curly braces that runs when the condition is true. In this for loop, we're creating an integer variable with the name I and a starting value of 40. I chose 40 as the starting value because I think the speaker sounds best at 40 Hz and above. The condition checks if I is less than 1000. If it is, the code between the curly braces will run, and then I++ will increase the value of the I variable by 1 before checking the condition again. Inside this for loop's curly braces, we have a tone function with the argument A5 for the port where we're playing the tone, and the Hertz value we want to play on that port. In the past, we've used numbers like 500 to play a tone of 500 Hz on the speaker, but here we're using the value of the variable I, which we know is going to change every time the for loop runs. So we're going to replace a number value with that variable value. Next, we're using the delay function with an argument of 10 to pause for 10 milliseconds, or 0.01 seconds, before the for loop finds its closing curly brace and increases I by 1 and checks the condition again. This first for loop is going to run 960 times, from 40 to 1000, before the condition is not true anymore, and the for loop ends. The void loop will continue to run, and the next line of code that it finds to run is another for loop. This for loop has the same structure, creating a new variable I and giving it a starting value of 1000, setting a condition that checks if I is greater than 40, having a change to that variable, which is I minus minus, which subtracts 1 from the variable, and having code between the curly braces that runs when the condition is true. It's important to remember that this I variable is completely separate from the one we created on line 10. Even though they have the same name, when you create a variable inside the parentheses of a for loop, that variable only applies for that for loop. It doesn't apply anywhere else in the void loop. Now let's look at how this loop is going to run when you have your speaker plugged in. I will start at 40, and because I is less than 1000, the condition is true and the code between the curly braces will run. It's going to play a tone of 40 Hz on port A5 where your speaker's plugged in. After a delay of 10 milliseconds, the for loop comes to its closing curly brace and it runs I++, increasing I from 40 to 41. 41 is still less than 1000. So the condition is true, and the code between the curly braces runs again, playing a tone of 41 Hz on port A5. There's another delay, the end of the for loop, and then I goes from 41 to 42. The condition is still true, so the code between the curly braces runs again, and so on. This loop is going to run until I equals 999. At that point, we'll play a tone of 999 Hz on port A5 and delay for 10 milliseconds before the program reaches the end of the for loop and increases I by 1 last time. Now I has gone from 999 to 1000. When the condition is checked, is 1000 less than 1000, it's false. So the code between the curly braces is going to be skipped over. That for loop is complete. The program is going to fall to the second for loop, and at this point, we still have a tone of 999 playing on the speaker. This for loop sets a new integer I to a value of 1000, and because 1000 is greater than 40, the condition is true, and we're going to play a tone of 1000 Hz on port A5. The code will delay for 10 milliseconds before reaching the end of this for loop, and then I subtracts 1 from the value of I. Now it's 999. 999 is greater than 40, so the code between the curly braces runs again, playing a tone of 999 Hz on port A5, delaying 10 milliseconds, and then subtracting another 1 from I. Now I is 998. This second for loop is going to run 960 times until I equals 41. Then we'll play a tone of 41 Hz on port A5, delay 10 milliseconds. The for loop will reach its closing curly brace and subtract 1 from I, moving it from 41 to 40. 40 is not greater than 40, so that condition is false, and the code between the curly braces is skipped. At that point, the code is going to find the end of the void loop on line 20 with this closing curly brace, and it's going to jump back to line 10 and start the first for loop again, creating a variable I, setting it equal to 40, checking the condition, and then running the code between the curly braces, increasing the value of I and playing higher and higher tones. Because these for loops are so well matched up, starting at 40 and going to 1000, and then starting at 1000 and subtracting to 40, it's going to have a smooth tone that rises from 40 to 1000, then falls from 1000 to 40, and then rises back up again.